We have some fun topics to talk about this week. We're going to do embryos, stem cells, cloning, and using one baby for the life of another. So, good stuff. But I want to start with a little bit of historical context. Um, in 1973, Roe versus Wade made abortion legal in all states. And as soon as those laws were passed that permitted abortions, researchers were able to legally begin to experiment on live born fetuses, which seemed to be degrading human life at the time. 5 years later, as you may recall from last week, Patrick Steptoe and Robert Edwards reversed infertility by creating the first test tube baby, Louise Brown. And here I found the newspaper article from when Louise Brown was born. By doing this, by accomplishing this and using this in vitro fertilization, through that process, they created and destroyed about 100 human embryos. So the creation of babies, just like it is today, back then, using in vitro fertilization, we've kind of developed the unintended byproduct of sacrificing human embryos that did not get implanted. We talked about this also last week. In 1979, Howard and Georgiana Jones established an in vitro fertilization clinic in Eastern Virginia Medical School, and in 1981, they helped to create the first American baby born by in vitro fertilization, and she was Elizabeth Carr. And while that embryo became a baby, while it was being formed, and while she was being born, there were protesters outside who were adamantly against this whole process, particularly the conservative Christians who saw in vitro fertilization as being alien, as suspect, as the scientists are creating life in unnatural ways and violating natural law. So that really was all of that was the beginning of the debate and the politics around embryos and what we're allowed to do with embryos and how we can use them. There was a case of Maria and Elsa Rios, which was kind of at the forefront of this ethical debate. And they were a wealthy couple from the United States, and they died childless in 1981. They had created embryos and they had frozen embryos for future children. But because none of them, and actually their embryos were in Australia, they hadn't thought about what their death might do to the embryos. So when they died, the question arose as to whether these embryos could be destroyed, should they be implanted in a surrogate, and then if they were implanted in the surrogate, would the babies born of that from those embryos and through the surrogate, would those then children then be entitled to inherit their fortune? So a committee was convened in Australia, and it required the scientists to be able to preserve those embryos until they were adopted. And unfortunately, those embryos never were adopted before they deteriorated and were no longer viable. So it became a moot point, but it was really one of those cases that brought the use of embryos and what is the responsibility to destroy or maintain embryos to the forefront of attention. Another case that also did a similar thing in bringing this issue to the forefront was the Davis case. And in 1990, Sue and Junior Davis, they were from Tennessee, they got divorced and they fought for custody of their 7 embryos that were frozen in an in vitro fertilization clinic. Mary Sue got remarried and she wanted to donate the embryos to an infertile couple, but the former husband, disagreed. In 1992, the Tennessee Supreme Court decided that Junior didn't need to become a father against his will. These were his children. So they said, has the right to not become a father. After that, a lower Tennessee court ruled that he could destroy the embryos, which he did. That cases like this led to the Human Embryo Research Panel, which was convened in 1994, and this panel concluded that the federal funding of research with embryos would improve the success and safety of procedures to reduce infertility, and that prohibiting any federal funding would harm the quality of such research. But what they did is they created terminology for the different types of embryos that might be subject to research. So it called embryos created specifically for research embryos, and those left over after successful in vitro fertilization as spare embryos. So when couples had frozen multiple eggs, they had all of the children that they had intended to have. Whatever eggs were left over, they considered those to be spare embryos. So the panel rejected the compromise that research could be done only on spare embryos. As you might expect, those leftover embryos from couples unsuccessfully attempting in vitro fertilization had higher rates of genetic abnormalities because they've already kind of picked the best ones, the most viable embryos out of all the ones that were available. So they didn't want to do research on just those embryos based on the perception that there would be some flaws in those. So would the research be reliable? Probably not. So they fought that. Another important historical event was 1996 when Congress added the Dickey-Wicker Amendment to the National Institute of Health's appropriation bill. And in that bill, it stated that none of the funds made available in the act may be used for research in which a human embryo or embryos are destroyed, discarded, or knowingly subjected to risk of injury or death greater than allowed for research on fetuses in utero. So in essence, they were saying, no, you're not going to get federal funding for research on embryos. So we're, going a little bit back and forth. Finally, there's a couple more historical things, but Marl Hughes was a famous geneticist, and he was famous particularly for breakthroughs in his technique of taking DNA from a single cell of a human embryo and testing it for cystic fibrosis. And when he did that, the process that he used in taking the cell didn't damage the healthy embryos. But the testing did mean that the embryos with cystic fibrosis would be destroyed. So that was pretty controversial. So although at the time there was this ban on the federal funds and it had remained in effect, scientists like Hughes were able to continue to do their research if it was privately funded. So if they got funding from private charities like Planned Parenthood or March of Dimes, so he was able to continue to do that. He actually ended up losing federal funding later on because it was kind of a stupid thing. He lost the federal funding because federal funding had paid for a refrigerator that was mistakenly placed in his private lab. So he had some issues that happened through basic stupidity. You may have heard of one of the more famous issues. Dolly the sheep was cloned in 1997. Oh, as you see as you go along, I've got these links. I've put some contextual resources within this PowerPoint so that you can click on them and see some of these things. And I do want you to look at them because sometimes it's case law, sometimes it's just a video related to the topic. Really interesting. Most of them are generally kind of brief, but it just gives you a little bit more information on each of the things that we're going to talk about. One of them being Dolly the sheep. Dolly the sheep, I remember when I was younger, this was a huge issue. Lots and lots and lots of controversy. So in February of 1997, every newspaper in the world was announcing that a lamb named Dolly had been created by cloning. She had actually been born before that. She was born in 1996, but because they were trying to get patents on the techniques filed before they made the announcement, those finally came through, and then they made the announcement about Dolly's birth. So previously to this, they had thought cloning was impossible to create mammals and really was a scary thing that people were talking about. It was something out of science fiction. It wasn't something that, happened in our lifetime. But when Dolly was born, it really galvanized the interest in cloned human embryos. Like, if we're applying this to animals, how soon is it going to be till we are going to be doing this with humans? And so, again, it was lots and lots of back and forth between conservatives and, people, scientists who really felt there was a value in doing this. So this cloning, the science of cloning, it's considered an ambiguous term even in science. And there are lots of different ways that it's been referred to and can be called: molecular cloning, cellular cloning, embryo twinning. So lots of different terms. But the process by which was used actually to clone Dolly was fusion. And that puts the donor cells next to an egg and fuses the two with an electrical current. Because that pulse that produces the fusion activates egg development, an embryo starts to develop. So at a 1997 conference on cloning, the Ian Wilmot, who was Dolly's originator, stressed that the technique was inefficient. He had started with 277 sheep eggs and got only one live lamb. However, that comment has been misinterpreted and misunderstood because he's emphasized how many eggs he started with and not how many of the fetuses resulted in live births. The actual statistics were that there were 277 eggs fused, 247 were recovered from the oviducts, 29 were transferred to create 13 pregnancies in lambs, 3 of which came to birth, and Dolly was the only one who was healthy and lived. So while the creation of Dolly was huge news, the process of getting there wasn't as widely publicized, and all of the failures and all of the, not necessarily failures, but non-successes weren't really talked about to this degree. It was a little bit later, 1998, where the stem cells that were found in, actually, I'm going to end here because I see that I'm almost out of time and I don't want to start this one yet.